Hey there guys, welcome to the video. My name is Pushpinder Gill, and in this video we're going to be talking about HCF and the LCM, right? So we're going to be talking about the basics concept of it, and then we're going to be talking about how is it tested in some standardized tests such as GRE, GMAT and CAT, right? So we're going to be talking about that. So let's go ahead and get started guys, right? So I'll actually start with the basic concept. So I'm going to start with the basic concept of an LCM, right? So what is an LCM? An LCM is a least common multiple of two numbers. So it's the least common multiple of two or more numbers. So what do you mean by least common multiple? So let's suppose if I say I have two numbers, let's suppose 6 and let's say 5. Now what I'm going to do is I'm going to list down the multiples of 6. So the multiples of 6 are going to be 6. The next one is going to be 12. The next one is going to be 18. The next one is going to be 24, 30, 36 and so on. And similarly for 5 is going to be 5, 10, 15, 20, 25, 30, 35 and so on. So if you can see, what we have to do is, now I'm going to break this into three parts. I have to find the least. So I'm going to start with the multiple. I have to find a multiple which is common to both the numbers. So, and it's the least. So I have to find the first multiple which is common to both the numbers. You can clearly see that 30 is the number which is common to both, and there is no number before 30 which is common to both. Which means I can say that the least common multiple of 6 and 5 is actually equal to 30. So that is what you mean by the least common multiple. The multiple which is common and is the least. Now how do you find the least common multiple from questions? So let's suppose I want to find out the least common multiples of two numbers x and y, or let's suppose three numbers x, y and z. So if I want to find the least common multiples of x, y and z, and let's suppose x is equal to 2 to the power a into 3 to the power b into 5 to the power c and so on, and y is also 2 to the power a into 3 to the power b and 5 to the power c and so on. So what is this? This is nothing but the prime factorization of x and y. So what is this? This is nothing but the prime factorization of x and y. Now LCM of x and y will have the highest power for each prime number. So 2 to the power, whatever highest, it's a or b, or let's suppose this is PQRS, whichever it is, it's not of concern. So whatever the highest power they're going to be there, that will actually give you your least common multiple. Now why do we pick up the highest power? Because let's suppose if we have two numbers, let's suppose I have a number 12 and I have a number 18. I want to find the LCM of 12 and 18. So 12 is something which can be written as 2 to the power 2 into 3 to the power 1, and 18 is something which can be written as 2 to the power 1 into 3 to the power 2. Now I have two numbers here, 2 and 3. What I'm going to do is I'm going to write down the highest powers. So the highest power of 2 is 2 and the highest power of 3 is also 2. Now why am I writing the highest power? Because 3 to the power 2 is already covering 3 to the power 1, so I don't need to write it again. So which is why the LCM of 12 and 18 is actually equal to 4 and 9, which is equal to 36. So LCM of any two numbers x and y is actually equal to the product of all the prime numbers which are common to x and y and raised to the highest power in whichever they are. So if they're highest in x, so you write that part. If they're highest in y, you write that part. So this is how you calculate LCM between two numbers. I'm going to take another example. Let's suppose I want to find out the LCM of 20, 15 and let's say 30. Well, one best way is to just look at these numbers and say, you know what, 30 is not divisible by 15, is not divisible by 20. We pick up the highest integer. The next multiple of 30 is 60, and as you can clearly see, 60 is divisible by 20, is divisible by 15, is divisible by 30. That means 60 is the LCM. But if you want a more formal way, what you're supposed to do is supposed to break it down into prime numbers like this. You're supposed to break it down into prime numbers like this and like this. And then what we're going to do is we're going to raise them to their highest powers. Now 3 highest is 1, 2 highest is 2, and 5 highest is 1. So which means the LCM of these numbers is going to be equal to 60, is just the way we predicted. right? So this is the least common multiple of these numbers. Now let's talk about the highest common factors of two numbers. Now how do you find the highest common factor? So I'm going to list down two numbers, 6 and 12, and I'm going to list down the factors of 6. So the factors of 6 are 1, 2, 3, and 6. And the factors of 12 are 1, 2, 3, 4, 6, and 12. Now what do you mean by the highest common factor or greatest common factor? It's the factor which is common to both of them. So what are the factors which are common to both of them? 1, 2, 1, 2, 3, and 3. And is the highest, which means 3 is the highest common factor of 6 and 12. Right? So this is how you find the highest common factor. This is one way of finding out. Another way of finding out is, if you want to find out the highest common factor of 6 and 12, so what do you do is you write down 6. 6 is 3 times 2. And you write down 12. 12 is 2 squared times 3. Now what you do is you write down all the prime numbers associated and you raise them to their smallest powers now, because you want something which is common to both. So it's 2 to the power 1 small or 2 to the power 2 small. 2 to the power 1 is small. Is 3 to the power 1 small or 3 to the power 1 small? 3 to the power 1 is small. Fine, which is actually equal to 6. So let's see, I made a mistake there. The highest common factor is 6. This is a factor which is also common, which is why 6 is the highest common factor. Fine, so it's not 3, it's actually equal to 6. So this is a more formal way of finding out the highest common factor. So let's suppose I want to find out the highest common factor of 15, 20, and let's say 35. Right? So 15 is going to be 5 times 3. 20 is going to be 5 times 2 square, and 35 is going to be 5 times 7. Now I'm going to write down all the prime numbers listed there. Now the highest power for 5 is 1, because it's 1 here, 1 here, 1 here. The highest power of 2, and be careful here, it's 0, because 2 is not available here, which is why the smallest power for 2 is 0. So you need to find the smallest power. The smallest power for 3 is again 0, because 3 is not present here. And the smallest power for 7 is also 0, because 7 is not present here, which means the highest common factor is equal to 5. Fine. So suppose you're understanding this point over here, guys. Pretty easy stuff. You must be knowing this already. So now I'm going to talk about some important fun things here. Now let's suppose if I want to find out the lowest common multiple of fractions, right? So let's suppose I want to find out the lowest common multiple of 1 over 2, 3 over 4, and 5 over 7. So then how I'm going to find that? I'm going to say the lowest common multiple of fractions is equal to the lowest common multiple of the numerators divided by the highest common factor of the denominators. Right? So I'm not going to prove this for you. It's just that you can remember it this way. It's actually much better. So what you have to do is you have to find the lowest common multiple of 1, 3, and 5. That numerators are the top numbers, divided by the highest common factor of the denominators, which is 2, 4, and 7. So the lowest common multiple of 1, 3, and 5 is simply going to be 15, and the highest common factor of 2, 4, and 7 is going to be 1, which means the lowest common multiple of all these numbers is actually going to be equal to 15. If you divide any of these by 15, you will actually get the answer. You'll actually get an integer. Another thing, the HCF of fractions is again similar, in which that is equal to the HCF of the numerators divided by the LCM of the denominators. So similarly, if I have to find the HCF of these fractions 1 by 2, 3 by 4, and 5 by 7, that would be equal to the HCF of 1, 3, and 5, and the LCM of 2, 4, and 7. So this is going to be equal to 1, and this over here is going to be equal to 28. So that means this is the HCF of these three fractions. Fine. So I suppose you're understanding this point over here, guys. Now another point that you need to understand is that, let's say if the HCF of any two numbers, let's suppose x and y, is equal to, let's suppose, h, right? Then the HCF of x and x plus y is also h. Then the HCF of x and x minus y is also h. And the HCF of x plus y and x minus y is also h. Let's actually put that to test. Okay, so let's say I want to find out the HCF of 12 and 6, which is actually equal to 6. As you can see, 6 is the number which is divisible by both. Then what is going to be the HCF of 12 and 12 plus 6, which is still going to be 6, because HCF of 12 and 18 is 6. Then the HCF of 12 and 12 minus 6 is actually still going to be 6, and the HCF of 12 plus 6 into 12 minus 6 is still going to be 6. So this is something that will help you to be faster in some questions. Fine. So suppose you're understanding this point over here, guys. Another point that I want to raise is that if I have two numbers, let's suppose A and B, the product of two numbers is equal to the LCM of two numbers times the HCF of the two numbers. So this is a very, very important expression, that is, the product of two numbers is equal to the product of their LCM and their HCF. Let's say, for example, I pick up two numbers, A is equal to 12 and B is equal to 6. So the LCM of these numbers is 12 and the HCF of these numbers is 6. So as you can see, A into B is equal to LCM into HCF. Let's pick up another example. Let's suppose the two numbers are 45 and equal to let's say 45 and let's say 30. So the HCF of these numbers is 30 and the LCM, no, it's not 30, I'm sorry, the HCF of these numbers is 15, and the LCM of these numbers, if you calculate, it's going to come out to be 90. So you can see 45 into 30 is equal to 15 into 90. That is, the product of two numbers is equal to HCF times the LCM of these two numbers. Fine. So suppose you're getting my point over here, guys. Now let's go ahead and solve some questions on it, so that it's much more clear to you. So the question says that which of the following is the lowest positive integer that is divisible by the first 7 positive integer multiples of 5. So we have to find the LCM, lowest positive integer, which is divisible by the first 7 positive integer multiples of 5. So it has to be first positive 7 multiples of 5. So 5, then 10, 15, 20, 25, then we have 30 and 35. So we have to find a number, LCM, which is divisible by all these numbers. Now what we're going to do is, this is nothing but 5. This is 5 times 2. This is 5 times 3, 5 times 4, 5 times 5, 5 times 6, and 5 times 7. So these are these 7 numbers here. Now the LCM is actually going to be equal to, so what do you have? You have 2, you have 3, you have 4. Sorry, I'm just going to list down the prime numbers. You have 2, you have 3, you have 5, and you have 7. So what's the highest power for 2? See, this is 5 into 2, 5 into 3. This is 5 into 2 square. This is 5 square. This is 5 into 2 into 3. So the highest power for 2 is 2. The highest power for 3, as you can see, is 1. The highest power for 5 is 2. And the highest power for 7 is 1. Because we have to find the LCM. So we'll be looking for the highest powers. So then it becomes 4 times 3 times 25 times 7. 25 into 4 become 100. And 7 into 3 becomes 21. So that means this is 2100. So 2100 is the lowest number which is divisible by 5, 10, 15, 20, 25, 30, and 35. Fine. So I suppose you're getting my point over here, guys. Let's move forward to our next question. So this says which of the following is the lowest positive integer that is divisible by, so we have to find the LCM of 8, 9, 10, 11, and 12. Again, let's break down 8, 2 cubed. Let's break down 9, 3 square. Let's break down 10, 5 times 2. 11 is just 11. 12 is 2 square into 3. Now the LCM is going to be 2 into 3 into 5 into 11. These are my prime numbers. The highest power for 2 is 3, for 3 is 2, for 5 is 1, and for 11 is 1. So my LCM is going to be 8 times 9 times 5 times 11. 8 times 9 is 72 times 5 times 11. 72 times 5 is 360 times 11. You multiply any number by 11, this is what you do, 0693. That means this over here is our answer. Fine, I suppose you're getting my point over here, guys. I hope I'm not too fast. This is a video, you can just pause it and rewind it. But whatever I've said, it's the most efficient way of solving this problem. Okay, so let's see it. Let's see. Now this over here is a data sufficiency question, right? So just a second. Let's start from here, guys. Okay, so this says the greatest common factor of 16 and positive integer n. So it says the HCF of 16 and n is 4, and the HCF of n and 45 is 3. So the question says which of the following could be the value of n, right? So it says which of the following could be the value of n. So what I'm going to do is I'm actually going to use the answer options there. So I'm going to use 6 first. So what is the HCF of 16 and 6? That is actually equal to 2. But it's supposed to be 4. So eliminate it. I'm going to try 8. What is the HCF of 16 and 8? Which is actually equal to 8. Gone, because this is supposed to be 4. Let's try answer option 9. What is the HCF of 16 and 9? That's 1. Gone. Let's try 12. What is the HCF of 16 and 12? That is equal to 4. Fine. And what is the HCF of 12 and 45? Again equal to 3, because there's no number bigger than 3 which is divisible by 45 and 12. That means D over here is my answer. Fine. So suppose you're getting my point over here, guys. Let's move forward to the next one. He says x and y are positive integers. Which of the following cannot be the greatest common divisor of 36? So we have to find which of the following cannot be the HCF of 35x and 20y. Now what do you mean by HCF of this and this? So that means if I say 35x over the HCF will give you an integer, fine, and 20y over the HCF should give you an integer. Now if you look at answer option A, 35x over 5 will give you an integer, and 20y over 5 will give you an integer. If you look at in the similar way, if you look at answer option C, that is 20x, 35x over 20x will give you 35 over 20. Is that an integer? Not an integer. Which means that there is no way you can get an integer here in any possibility. That means C is something, 20x is something which cannot be the highest common factor of these two numbers. Rest every answer option could be. So I'm not going to waste my time trying to find that could be. Well, if you were not equipped with this concept, you would have chosen to plug in some numbers into this problem. However, you know what HCF is now, then you can be a lot faster. You can just solve this in a minute, right? So that means what I'm saying is that any number divided by its HCF is supposed to give an integer, and 20x is something which is not giving us an integer, which means 20x is our answer. So thank you very much for watching this video, guys, and I hope you've understood this part. So make sure that you practice on it. Practice is the only thing. I've given you all the tools which are required for you to tackle the HCF LCM problems. Well, I'll do more videos on some difficult questions which I'll be solving for you guys for HCF and LCM. We're going to do that video in the future. So thank you very much for watching. Don't forget to explore our website. We have a lot of stuff. Come on this website, explore that. This is a Facebook page. Give us your valuable like and give us your valuable feedback at this email address. So this would be about this video, guys. Thank you very much for watching.